Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2022, paper 5, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1. Jamie was paid £14 per hour. Jamie receives a pay increase of 20%. Work out how much Jamie is now paid per hour. Okay? Right, so this is the non-calculator paper, so I'm going to use a non-calculator approach to do this. So I've got 100% to start with. Always given 100% to start with, and that's £14, isn't it? Okay. Now I want to increase it by 20%. Now the easiest thing to do is to find 10%. 10% is just dividing by 10, that is £1.40. Now to make 20%, I could either double that up, or sometimes it's just easy just to write down another 10% like that, and then kind of add it all up, because if I then add 100% and 10% and 10%, I'll get 120% of my original amount. So adding all up on the right hand side, 0, 0 and 0 is 0, 0, 4 and 4 is 8, 4, 1 and 1 is 6, so that's £16.80. That's nice, £16.80. Good pay rise. Question 2. Find all the possible integer values that satisfy the inequality minus 4 is less than or equal to x minus 3, which is less than 1. Okay. Right, now we can kind of deal with these very similar than we do with equations, where as long as we do the same thing to both sides, it stays balanced. So here we've actually got two symbols, so it isn't really a balance. You can't have a balance with two fulcrums. And you've got three separate parts. But as long as you do the same thing to those three parts, then again, it should all kind of stay being true. So if I add 3 to the middle section, I hope you see that that's going to cancel with that, leaving me just with the x. So doing the same to the other two parts as well, that's going to give me -1 is less than or equal to x, which is less than 4. Okay, so on a number line, if I had a number line like this, which was going from -1 up to 4, then x is going to be any value between those two endpoints, isn't it? Now it can be the left-hand limit because that is part of the range, but it can't be the right-hand limit because that's kind of beyond, because x has to be strictly less than 4. Okay, so what are the integer values then that satisfy this? Well, you can have 1 -1, can't you? That's one of the solutions, but you can also have 0, 1, 2 and 3 in there, can't you? 0, 1, 2 and 3. So then these are all the integer solutions that lie between that range. So my answer is going to be -1, 0, 1, 2 and 3. Question 3. Asmi spins the spinner twice and adds the two scores to get a total. Complete the table to show all the possible totals. Well, you can see that the spinner's got the numbers 2, 5 and 8 on it. So we've got 2, 5 and 8 along the top and 2, 5, 8 down the side. So then the numbers in the middle are going to be what you get by adding the two numbers at the top of the row and to the left of the column, like that. So that 2 and 2 make 4. Okay. So then the number on the end here, in this square here, that's going to be the sum of 2 and 8, isn't it? So 2 plus 8 is going to be 10. And similarly, 5 and 8 make 13, and 2 and 8 make 10. So completing the table like that. Got 10, 13, 10. Find the probability that the total is a square number. Right, so the probability that it is a square, well, when you work out the probability, it's successful outcomes divided by total outcomes. Now, how many outcomes are there altogether in this question? Well, each outcome is each one of the cells in the table, and there's a 3 by 3 grid that gives you a total of 9 different outcomes. Okay, so the denominator is 9, and now the numerator is going to be the successful outcomes, and in this case, success means that it's a square number. Okay, just get rid of that. So which one of those numbers are squares? Well, if you think about the square numbers are 1, 4, 9, and then 16 then, aren't they? It doesn't go any higher than 16. So have we got any 1s, 4s, 9s and 16s in our tables? Well, we've got a 4 there, and we've got a 16. Have we got any others? Nope, no 9s, no 1s, just 1, 4 and 1, 16. So altogether there are 2 outcomes that happen to be square numbers. So then the probability of success is 2 over 9. 2 successful outcomes, 2 squares over a total of 9 different outcomes. Question 4. Layla and Jamal open a box of sweets. Layla and Jamal share all the sweets in a ratio of 2 to 3. Write down the fraction of sweets that Layla receives. Okay, so we want to turn that ratio into a fraction. Now, if Layla gets 2 shares and Jamal gets 3 shares, then altogether there are 2 plus 3 equals 5 shares. Okay, so then what fraction does Layla receive? She received her 2 shares out of a total of 5 shares. So basically she's got 2/5 of the total, hasn't she? Now, part B says Layla eats some of her sweets. She is then left with 18% of the sweets that were in the box. Work out the percentage of her sweets that Layla has eaten. Now, these questions where they don't actually tell you the total, they do throw students a little bit. Now, there's no evidence anywhere in here of how many sweets are in the box. And so you just have to kind of assign it a value. I'm just going to assume that there are 100 sweets. Now, if they're not 100 sweets, then it should still follow the same ratios, so it's not really a problem. Okay, so if I assume there are 100 sweets, then Layla's share, she's going to get like 100 sweets times her fraction of 2/5, isn't it? So what's 100 times 2/5? Well, 5 goes into 100 20 times, and 20 times 2, that's 40. So she gets 40 sweets. Okay, so let's say, assuming that they got 100, might not be. Okay, so then if she's left with 18 sweets, so how many has she eaten? So she's eaten her 40 sweets minus the 18 sweets that were remaining. So that means that she ate 22 sweets. So then the percentage of her sweets that she's eaten That's going to be the 22 sweets that she ate out of the total 40 sweets that she had to start with. Now, what's that as a percentage? If you want to get that into a percentage, we need to get it as a fraction over 100. 40 doesn't immediately go into 100, but if I divide it by 2 first and get it as a fraction over 20, then that's going to be like 11 over 20. And then if I times that by 5, I'm going to get that as a fraction over 100. That's 55 over 100. And then 55 over 100, I can definitely write as a percentage. It's 55% then, isn't it? Okay. Question 5. Ashley goes on a journey. She travels by taxi for 1/8 of the journey. She travels by train for 4/5 of the journey. She walks for the remaining 900 meters of the journey. Find the length of the journey in kilometers. You must show your working. Okay. So we've got two different fractions here representing different parts of the journey. So we've got the taxi part of the journey. So let's say if it was a line. So we did a bit by taxi, did a bit by train, well, quite a lot of it by train actually, and we did a little bit by walking. Okay, so taxi part, train part, walkie part. Okay, so now we know that the taxi part was 1/8, and we know that the train parts was 4/5. So then the walkie part has got to be the remainder then, isn't it? Which we happen to know is also 900 meters. Okay, but we don't know what fraction of the journey it is yet, but we can easily work that out, can't we? I just wrote that down rather appallingly. I'm going to just write that properly. Okay, so if I add those two fractions together, like that one and that one, then I should be able to work out what's left over and pair it up with the walking bit then, can't I? So let's start by doing that. Let's add those fractions together. So what is 1/8 plus 4/5? So I've got two different denominators here, 8 and 5, but luckily they both go into 40. So let's write them as fractions over 40 then. So 8 into 40 go 5 times, so that's going to be 5/40ths. And 5 goes into 40 8 times, and 8 lots of 4 is going to be 8, 16, 24, 32. Okay, so I've got 5/40ths and 32/40ths, which adds up to 37/40ths. So the walking fraction is going to be 1 minus that then, isn't it? That's going to be the remaindery part. So what is 1 minus 37/40ths? Well, 1 is 40/40ths, and 40 minus 37 is 3. So that's 3/40ths. So then that section there is going to have to be 3/40ths, and it kind of pairs up with 900 meters then. So if I take a number, the total distance, and I times that by 3/40ths, I get 900. Okay, so then taking that fraction and flipping it over and multiplying the other side, or another way to think about it is, timesing both sides by 40 divided by 3, I should get that the total distance is going to be the 900 meters of the walkie part times the 40 over 3. Okay, I'm basically dividing through by that same fraction, which is flipping over and multiplying, aren't I? Okay, so what is 900 times 40 over 3? Well, 3's into 900 goes 300. So 3's into 900 goes 300. And 300 times 40, well, 3 times 4 is 12. 12, and then I've got 1, 2, 3 extra zeros. So that's 12,000. So that's 12,000 meters. So what's that in kilometers? 1 kilometer is 1,000 meters. So dividing that by 1,000, I'm going to get 12 kilometers. So the length of the whole journey in kilometers is going to be 12. Question 6. The graph shows information about the population of a village. And we've got population written in thousands up the side, and we've got years running from 2015 to 2022 along the bottom, although the graph seems to stop at 2020. Right, the population of the village in 2021 was 4,740. Plot this point on the graph. Okay, so we've got an extra one to plot on. 4,740. Now note these are in thousands here, so that 4.7 there is 4,700, and the 4.8 is 4,800, and there are 5 divisions in between, so each one of those must be 20. So I want to go 2 divisions above 4.7 to plot my point for 2021. So I think mine goes about there. Okay, right, so then I should really join that up with a straight line, because, well, a dashed line, not a dash straight line, because that's what's happening. So let me just dash my way up to 2021. Okay, that'll do. Right, so that's the first bit done. Work out the increase in the population of the village between 2016 and 2018. Okay, so what was the population in 2016? In 2016, it was here, look, which is 2 little squares below 4.2. Now remember, each one of those was 20, so that would be like 40 below 4,200, so that's 4,160 there. And then the other one at 2018, that's up here now. Now that is 1 little square below 4.5, so 4,500 minus 20, that would be 4,480. Okay, so how far is it between these two values then? What we're interested in is the difference then, aren't we, of those two numbers. So what is 4,480 minus 4,160? Well, I'm just going to do a straightforward subtraction. So that's giving me 320 difference. So that's 320. Part C says, Rowan says that there was a huge increase in the population of the village between 2015 and 2020. Describe how Rowan may have been misled by the graph. Well, I think what he's thinking of is, well, if you look at 2015, the height of the bar is pretty low. Look, it's just like this little wibbly bit here, and then if you're looking at this, that looks like loads taller. But actually what's gone on here is that the graph isn't starting at 0. We're already at 4,000, and we've just increased to 4,700, which is, you know, it is an increase, but is it a massive increase? No, it's not a massive increase. So I think he's been misled by the fact that there is a broken scale and it hasn't been marked. So the graph uses an unmarked broken scale starting at 4,000 and not 0. Blake says the population of the village will be greater than 4,800 in 2022. Write down an assumption that Blake has made. So for it to go above 4,800, which would be here, isn't it? So he's expecting the graph to go above that. Okay, so what is he expecting to happen then? Well, I guess what he's expecting, if it's to go above 4,000, he's expecting it to kind of carry on in the same way as it has for the last couple of years. Okay, or the kind of general trend line. So if you look at so from 2015 up to 2021 and kind of drew a line, then you can see that it's kind of, yeah, it's going to go above 4,800 as long as it carries on the same way. So he's assumed then that population growth will remain constant. Population growth will stay similar to previous years. Okay, so he's assumed that it's going to be the same as previous years. Now, it might not happen. Something might happen in the village. Maybe it's midsummer, someone's been murdered and everyone leaves, I don't know. But yeah, can't just say it's happened like that for the last few years, so it's definitely going to happen like that in the future. Other factors may apply. Okay, so there we go. Question 7. The diagram shows a straight line crossing a pair of parallel lines. Find the value of y. You must show you're working. Okay. Well, I can see a couple of things going on here. I can see that we have got angles on a straight line from here to here. So I know that those two must add up to 180 between them. Okay. And I've also got what we call corresponding angles here, which is two angles on the same side of the transversal, on the same size of the parallel line. Okay, so those two are corresponding. Now we have to show working here, so we have to explain everything we do. So I'm going to start off by saying angles on a straight line sum to 180 degrees. Now, so that's the rule I'm going to use. So that means then that 3x minus 23, that little blue angle, plus the other side of the straight line, which is x plus 35, that is going to have to be equal to 180 degrees, isn't it? Okay. Now, adding my x's together, I've got a 3x and an x there. They add up to 4x. And I've got some numbers as well. I've got minus 23 and plus 35. Between them, 35 take away 23. They've got a difference of 12. So those two add up to 12. And I know that they have to be equal to 180. So subtracting 12 from both sides, I'm going to get 4x is equal to 168. And then dividing through by 4. 4 is into 168. What's that? 42. That means that x must be 42 degrees. Okay. So given that x is 42, then what is that corresponding angle then? So then 3x minus 23, that's going to be 3 lots of 42 minus 23. 3 42s, 42, 84, 126 minus 23. So that comes out to be 103. Okay, so then that angle there must be 103. So that must be y then as well then. So y must be equal to this. So that's y, and the reason for that is that they're corresponding. I should write that down somewhere. Y and 3x minus 23 are corresponding angles. Just explaining my steps. So 103 degrees. Question 8. The diagram shows a cylinder with radius 15 centimeters and height 20 centimeters. On the grid below, draw the plan view of the cylinder. Use the scale of 1 centimeter to represent 5 centimeters. Okay. So what is the plan view? So if I've got an object, then the plan view is the view. You can either consider it like to be the bird's eye view, the view if you were flying over and looking down. Another way of thinking about it is if you imagine it was a cookie cutter and you stamped it into the ground, then it's the shape that the cookie cutter would leave in the ground. So that's another way of thinking about it. So it's either like the footprint or the aerial view looking down on your shape. Either way, it's going to be a circle, isn't it? Because if you look straight down on this object here, you're going to be looking down on that circular top. So what we need to do is show that circle on the diagram. Now we need to be using a scale of 1 centimeter represents 5 centimeters on the actual thing. So if I picked a point in the middle, which is going to be the center of my circle, then that 15 centimeter radius would take me out to 3 squares. It'd be out to here, wouldn't it? So I need to draw a circle that is centered there and it goes through there. Now I think I could do it with my little tool here, but obviously for you, you're going to have to draw it with a compass and a pencil, carefully, like what I'm doing, but with your compass and your pencil, not your electronic one. But anyway, it should look something like that if you do it nicely with your compass and your pencil. Okay. Now part B says, on the grid below, draw the front elevation of your cylinder using the same scale. So the front elevation would be kind of looking at it from this angle. So if you were like walking past it and looked up at the building, what would you see? Now I think what you would see is you'd see this section, wouldn't you, if you look in, and it wouldn't look round though, it looked kind of straight like a rectangle. So it's going to look like a rectangle which has the same height as my shape, 20 centimeters, and the distance that you would see from here to here is going to distance is the diameter of your circle, isn't it? It's going to be 30 in that direction. So we're going to have a rectangle which is 30 by 20 in reality. Now if we're using the scale of 5 centimeters or 1, I'm going to divide that by 5, so that's going to be 6 and that's going to be 4. So we need to draw a rectangle which is 6 by 4 basically. So 6 by 4. It's going to be from, so let's say this was the top left corner, 1 2 3 4 5 6, 1 2 3 4. Then I should be drawing a rectangle using my rectangle tool from there down to there. Now you're going to be using a ruler and a pencil. Okay, mine kind of looks like that. Let's just make it a little bit bigger. Okay, yeah, so it's going to look like that, 6 by 4 like that. Now I do recommend that you do a little sketch like this before you start drawing on your square grid. The reason for that is that you've only got one little square grid, and if you fluff it up, then obviously it's a problem. So I would just do a little sketch on the side first, get all your dimensions right and get the idea of what the shape looks like in your head, and then draw it neatly in the grid. Okay? Question 9. A student says that they have placed the following values in order starting with the smallest. Has the student done this correctly? Show how you decide. Okay, so we're going to have to evaluate each one of these things and make sure they are actually in the right order. Okay, so let's have a look at the first one, 1 over 10 all squared. Now when you've got a power on the outside of a bracket like this and you've got a quotient or a fraction on the inside, the power gets distributed to both parts. So it's going to be 1 squared over 10 squared, which is the same thing as 1 over 100 there, isn't it? So that's 1/100th. Okay, as a decimal, that's going to be 0.01. Now, root of 0.25. Okay, similarly, well, I can write 0.25 as a fraction. That's 1/4, isn't it? Now, 1/4 square rooted, that's the same thing as root 1 over root 4 then, isn't it? Again, so applying the root to both parts of the fraction, that's the same thing as 1 over 2, which is 0.5. Okay, so that's substantially bigger than the first one, so they're all looking good. And then I've got 4 to the minus 1. 4 to a negative index is the same as 1 over the same number to a positive index. That's the same thing as 1 over 4 to the 1, or just a quarter, which is a decimal, is 0.25. Okay, so that's a slight problem because root 0.25 is actually bigger than 4 to the minus 1, and so she's got it the wrong way around. So is it done correctly? No, because root of 0.25 is bigger than 4 to the minus 1. So correct order is 1/10 squared, 4 to the minus 1, and then the root of 0.25. Okay, question 10. The parallelogram and the trapezium have the same area. The ratio x to y is 3 to 5. Find the value of x and the value of y. You must show your working. Okay, so we've got a parallelogram, we've got all the dimensions for it. We've got a trapezium where we've only got one of the dimensions for it. But I guess we can work out what those dimensions are by using the fact that they have the same area. So I'm going to find the area of the parallelogram first, and then I can equate the trapezium with it, and then hopefully I can then work out what x and y are. Okay, so let's start with the parallelogram. So the area of a parallelogram, you should know, is base times height. Now the base of this parallelogram is 8. The height is 5. So that's the base there, look from there to there. And the height is here, that's 5. So what is the 6 doing there? It's there just to confuddle you basically, isn't it? So we don't need that one. Okay, so it's just 8 times 5. It has an area of 40. Okay, so once we know that the area of the parallelogram is 40, then we know that the area of the trapezium is also 40. Now the area of a trapezium is a half times your a plus b value times your h value. Okay, so that is a half times, well, a and b are your two parallel sides. In this case, a is x and b is y. Okay, and then h is the distance between them, so h is going to be that distance there, look. Okay, so subbing those carefully in. So I'm going to get x plus y times 4. Okay, so what does that tell me? Well, I can cancel that half into the 4, giving me 2. So that's going to be 2 lots of x plus y. Now, I already worked out what the area was. It's equal to 40 because these two things have the same area. So if 2 lots of x plus y is 40, then x plus y must be 20. Okay, just dividing both sides by 2. So my values for x and y, they add up to 20, and they're in the ratio of 3 to 5. So I know that they're in the ratio of 3 to 5 and that they add up to 20. So how does that help me? I guess I could say that 3 plus 5 adds up to, so if you think about the ratio of 3 to 5, that kind of adds up to 8, doesn't it? So 3 plus 5 is equal to 8. Now I want the ratio parts to add up to 20. So what would I have to do then to make the ratio parts add up to 20? I think what I need to do is times it by like 2.5, because 8 goes into 22 and a half times. Double 8 gets 16, and half of 8 is 4, 16 and 4 make 20. Okay, so if I times it by 2.5, I'd get 20. So if I take this ratio of 3 to 5 and I times it by 2.5, then 3 lots of 2.5 is going to be, what's that, 7.5? 7.5, and 5 lots of 2.5, that's going to be 12.5. 12.5, okay? So that means I can say that x must be 7.5 centimeters and y must be 12.5 centimeters. Okay. Question 11. Write 0.27 reoccurring as a fraction in its simplest form. Okay. Now these ones, after you've done a few of these, they're all right. So what I do with these is I start with the value they give me, and I say that must be equal to x. So just going to write that down along. Rather than as 0.2 and 7 reoccurring, I'm just going to write it as 0.2727, 2727, and so on. Okay. Now, if I multiplied that up by 100 to get 100x, then I would shift the decimal point 2 along, and I would get 27 lots of 27.27272727, and so on. And so if I then deducted the first one from the second one, so if I take that x away from 100x, it will leave me with 99x on the left, and on the right, if I take 7 take away 7, 2 take away 2, 7 take away 7, 2 take away 2, I hope you can see that all of that is going to cancel with that, and you're left up with 27 minus 0, which just gives you 27. So I get 99x is 27, so then x is 27 over 99. Now, I can see that these might cancel because they both have 9 as a factor. 9 goes into 27, 9 goes into 99. So just dividing top and bottom by 9, just to simplify this fraction down a little bit, that's going to give me 3 over 11, which I don't believe factorizes anymore because they're both prime. So it's going to be that then, isn't it? It's going to be 3 over 11. Question 12. The time t seconds taken for each of 60 students to complete a puzzle is recorded. The table shows information about these times. Okay, so we got times from 20 to 30, 30 to 40, 40 to 50, 50 to 70, 70 to 90, and their frequencies. Part A says 2 students are picked at random. Reese worked out the probability that they both took longer than 50 seconds to complete the puzzle. Reese work-in is shown below. The number of students who took longer than 50 seconds is 30 plus 10, which is 40. The probability that one student took longer than 50 seconds is going to be 40 out of 60, which is 2/3. So the probability that they both took longer than 50 seconds is 2/3 times 2/3, which is 4/9. Explain the error in their method and write the correct calculation that Reese needs to do. You do not need to work out the answer to your calculation. Okay, so we just need to write down what the two things multiplied are, I guess, without having to work out what the answer is. Okay, well, I can see the answer to this, and the error is basically that Reese has assumed that the two events are independent. So I'm going to write that down. Reese assumed the two events were independent And by independent, I mean that the outcome of one doesn't affect the outcome of the other. Well, actually, what we've got going on here is like a tree diagram where you have got your 60 students, of which 40 are the students that you're picking from. So what we're doing, that they are, so just say that it's success, probability of success. So that would be 40 out of 60. So the probability of not success then is going to be 20 out of 60 in this direction. But when you get onto your second selection, then you've got fewer students, haven't you? Because you've already picked one, plus you've already picked one of the winning ones. So the probability of success on the second selection is going to be one less successful outcome, one less total outcome. Okay? Now that's going to cascade throughout the rest of the diagram as well, but we don't need to do all of that. We just need to explain that actually we need to go this route through the diagram and kind of put down the correct calculation for that then. So Reese has assumed that the two events were independent, but there will be one less student to pick from. So the correct calculation should be 40 over 60 multiplied by 39 out of 59. Now obviously on a non-calc paper that's going to be a bit of work, but we don't have to do that work because they said we don't have to. So yeah, as long as we've written it down, we're good. That's it. That's only 2 marks. We've got it. Part B says 2 students are picked at random from those who took 50 seconds or less. Find the probability that one of them took 30 seconds or less and the other took more than 40 seconds. You must show your working. Right, so let's just be clear, we're only picking from this section of the frequency table. So we're not interested in this part up here. Okay, they're not being picked from. It's just from there. Also notice there is nobody in the middle bit. So you can't pick anyone from here because there isn't anybody. So there aren't 3 categories here, and I got a bit confused when I first looked at this, that they had 2 disjoint groups that they were talking about, but then I realized there was nothing in the middle group. So there are 8 people which are 30 or less, and there are 12 people who are 40 or more. So there's only really 2 outcomes here, either they're 30 or less or they're 40 or more. So if we drew that on a tree diagram, so now I'm going to call this outcome L for getting 30 or less, and this one not L for not getting 30 or less. Now you can see the probability, well, there are 8 people who got 30 or less out of a total of 8 plus 12 out of 20. So that means that the probability of picking 30 or less is going to be those 8 out of those 20, and not less is going to be 12 out of 20 for the first selection. Okay. Now for the second selection, we're going to get less, not less, less, not less again. Again, we've got dependent probability because we're not replacing, are we? So we're taking a student and then we're taking another student. So if I picked a less one before, there's going to be one less, and there's going to be one less student. If I picked a less one before, I'm still going to have the same number of not less, but I'm going to have one less people to pick from. And then down this way, if I picked a not less, then I'm still going to have all my 8 less out of a total of 19. And then if I pick not less, then I've got one less not less, which is 11 out of a total of 19. Okay, so find the probability that one of them took 30 seconds or less and the other took more than 40 seconds. So that means they can either go the less not less route, or they can go the not less route. Either of those are the outcomes that we're looking for. So what is the probability of less not less? That's going to be 8 over 20 times 12 over 19, and the other route is going to be the probability of not less, which is 12 over 20 times 8 over 19. I hope some of these things cancel out. This is going to be pretty horrible. Right, so I don't like multiplying through by 19s. 19s are meh. Right, so can we do anything about this? So we're going to have to multiply those out and add them together, because the overall probability of one of each is going to be those 2 added together, isn't it? It's going to be those less, not less, plus probability of not less. So we need to work those 2 out. I don't want to work those out, it's too long. Okay, can I cancel them down a little bit first, maybe make it a bit easier? I guess I don't have to do it in its simplest form, do I? So if I just do 8 times 12, 8 12s are 96, and 20 19s, well 20 20s would be 400, so 20 19s would be 380, I guess. So that's 96 over 380, and that's going to just be the same because the numbers are all the same, they're just kind of in a different order. Okay, so then the probability of one of each is going to be 96 over 380 plus another 96 over 380. So adding the numerators together, keeping the denominator the same, that is going to be 192, I believe, over 380. I think that's the right answer. 192 over 380. Question 13. Points A, B, C, and D lie on the circumference of a circle. Line AC intersects line BD at point E. Prove that the triangle AED is similar to triangle BEC. Okay, so similarity means same angles. So what we need to show then that the three angles in AED match the three angles in BEC. Okay, so can we do that? So where are these two triangles first? So triangle AED is this one. So we need to find the three angles of this one compared to the three angles of this one. Now obviously we don't have any angles written on here, so we're going to have to give them angles, I guess. We could call them X, Y, and Z or something, and then show that they're equal to each other. Okay, let's start with the angle at E, because that one's fairly straightforward, isn't it? So here, what we've got is two vertically opposite angles, haven't we? So these two vertically opposite angles must be equal to each other. So I'm going to start with that. I'm going to say angle AED is equal to angle BEC because they are vertically opposite. Okay, so those two are equal. So then we've also got angles subtended from the same point. If you think about it, angles A and B, so the angle up here and up here, these two have got to be equal to each other as well because they're subtended from the same chord or arc. So they're both subtended from this chord here or arc here, DC. So they're both subtended from the same chord. So I'm going to say that DAE is equal to CBE, and the reason is because angles in the same segment subtended from same chord. Okay, and then finally we could say the same argument for the other two angles at the bottom here then. So this angle here and this angle here, they're both subtended from the chord AB, aren't they, or from the arc AB. Okay, they're both subtended off that same chord. So those two got to be equal to each other as well. So that angle there is going to have to be that angle there. So we can say then that ADE, angle ADE, that is going to be equal to BCE angle for the same reason. So that means that all of the angles match. Therefore, all three angles in both triangles match. So must be similar. Okay. Question B. The number of bees P in a colony is given by the formula P equals A times B to the power of X, where X is the number of months after the start of July. At the start of July, there were 25,000 bees in the colony. After 1 month, there were 23,500 bees in the colony. Oh no, that means it's decreasing, isn't it? So that means X is going to be fractional perhaps, so it's getting smaller each time. So find the value of A and the value of B and give the value of B as a decimal. So I guess what we can say that is at start of July, then we've got x equals, how many months has it been from the start of July? At the start of July, x is going to be 0, isn't it? Okay, so we know then that p, the population in the colony, being equals to a lots of b to the power of x. Well, if x is 0, so I'm going to get ab to the power of 0, and I know that the colony is actually 25,000 at that point, so I know that p must be 25,000. Okay, now any number raised to the power of 0 is 1, so b becomes 1, so I get a times 1, so basically I've got a there. So that tells me then that the value of a must be 25,000. Okay, that's our starting value then. Okay, so we've already got one of the values. So now we need to work out the other value, b. Okay, so after 1 month there were 23,500 b's. So that's going to be at start of August then, isn't it? At start August, which is 1 month later, x is going to be equal to 1. So p equals ab to the power of x is going to become 23,500 is equal to a, which we now know is 25,000, times b to the power of 1. Now b to the power of 1 is just b, so b times 25,000 is 23,500. So then b is going to be, dividing both sides by 25,000, is going to be 23,500 divided by 25,000. Okay, so what's 235 divided by 250? So those two cancel with those. It's left me with 235 divided by 250. So can I cancel that down some more? Because I want to convert it into a decimal. So 235 over 250. So to convert into a decimal, I want to try and get it over 100. Maybe if I divide it by 5 and then double it, that would get it over 100, wouldn't it? So if I divide that by 5, so 5's into 235, or so 5's into 100 go 20 times, so 200 be 40 times, and then 35 it goes 7 times, so that makes 47. 47 over 50, I make that. Okay, and then doubling that up then, just times in top and bottom by 2. That's going to give me 94 over 100, which is 0.94 then, isn't it? So that's what it is as a decimal, 0.94. So that means the bee population is falling by 6% each month, which is a bit of a disaster. Poor bees. Question 15a, simplify root 3 times root 15. Now, if you've got two roots multiplied together, you can combine them into one root. You can just put the two numbers under the same root symbol like that. So that's the same thing as root of 3 times 15. And the root of 3 times 15, that's the same thing as the root of 3 times 15, which is 45. Now, to simplify these down, you're looking for square factors rather than root 3 and root 15. Is there any factors of 45 that happen to be square numbers? Yes, you could use 9. I don't think there's any more than 9, so I could rewrite that as the root of 9 times what? 9 times 5? Okay, because that means I could then split it back up again into root 9 times root 5, and the root of 9 I can actually root, can't I? I can make it 3. So it becomes 3 root 5. So that one is 3 root 5. 40 over root 15, rationalize the denominator and simplify. Easiest way to rationalize denominator is times top and bottom by the denominator, like that. Root 15 over root 15 is just 1, so multiplying through by it is not going to change the value of the fraction. But what it is going to do is going to change that denominator from an irrational number into a rational one. Because root 15 times root 15, that's just 15, isn't it? So I get 15 on the bottom, and I'm going to get 40 root 15 on the top. Okay? Now, can I simplify that at all? Well, I suppose 40 and 15 both divide by 5, so that's 8 and 3. That makes it a little bit simpler. Can I do anything else? No, I don't think 15 has any factors that I can pull out that are square numbers. So I think that's all we're going to get. So I'm going to get 8 root 15 over 3. And then finally, work out 27 to the power of 4 thirds. Okay, now you can treat each part of this as a separate operation. So I'm going to deal with the third part first. So 27 to the power of 1/3, that is the cube root of 27. What is the cube root of 27? Cube root of 27 is 3, isn't it? Because 3 times 3 times 3 is 27. So that's going to give me 3 to the power of 4. So we've dealt with the cube root part. We still need to do with the factor of 4. So 3 to the power of 4, what's that then? So 3 times 3 is 9, times 3 is 27, times 3 is 81. So then the answer is going to be 81. Question 16. The graph shows the distance travelled by a particle over the first 20 seconds of its motion. Show that the average speed of the particle over the first 20 seconds of its motion is 1.8 meters per second. Okay. So average speed. Do you know the DST triangle? DST. Okay, distance, speed, time. Average speed, the S part of it is distance travelled over time taken. Okay, so average speed over the whole journey of this object is going to be the total distance travelled divided by the total time taken. Now obviously it starts off going quite fast and then slows down, but on average it has travelled a distance of, what's that at the top there? Is that exactly 35? No, it's the square above 35. It's 36, isn't it? So it's travelled 36 meters in 20 seconds. So then the average speed is going to be the 36 meters it's travelled in the 20 seconds that it took. So what's that? Dividing by 2 is 18. So it's going to be 1.8, I guess. So that's 1.8. Okay, so the average speed is 1.8 what? Meters per second? Yeah, we've done it there. So show that it's 1.8. We showed it's 1.8. I suppose we could just put the unit on the end to really show it. Okay, and then the second part says, estimate the speed of the particle at 10 seconds. You must show your work to support your estimate. Okay, so where is 10 seconds? So if you read up to the graph at 10, so just reading up from there, we're talking about this point on the curve here then, isn't it? What is the speed at that point there? Now the way to work out the speed from a distance time graph is the gradient, isn't it? We want to know the gradient at that point. Now this is a curving line, so we can't just take 2 points and do change in y over change in x, because that only works for straight lines. For this one, because it's a curve, we have to estimate it by drawing on a tangent first. So a tangent is a straight line just touching the curve at that point of contact. I can just draw that on my graph. I don't know if you notice, I kind of tried to make this either side of it about the same distance from the line. Anyway, kind of drawn that on. So that's my tangent. So then to work out the gradient, I'm just going to take 2 points that are easy to read. So I'm going to take, it goes off the top of the graph over there. Why don't I'm going to take the point itself. That might be the easiest thing to do because that's a nice easy point to read. So I'm going to take this point here, and I'm going to take this point down here as my two values that I'm going to work out the change in y and the change in x for then. Okay, so how far is it from there to there? I'll make a little triangle here. So that distance, look, that one's easy to work out because it's just 10. That's the time that we took. So that distance is 10. And then the change in y, it goes from 30 to 18. So that's 12 in that direction, isn't it? So my estimate for the speed at that point is going to be the gradient, which is change in y over change in x, which is 12 over 10, which is 1.2 then, isn't it? So that's 1.2 meters per second at that point. Question 17. The diagram shows the triangle ABC. Yes, it does. Find the area of the triangle. Give your answer in the form of A root B, where A and B are integers. Okay, so this is a non-right angle triangle, so we can't use area of a triangle as half base times height because we don't have two measurements at right angles to each other. I think what we're going to be doing is using the trigonometric version of the area formula, which requires two sides and the included angle. Okay, and the formula goes, the area of a triangle is half AB sine C, where A and B are two parallel sides and C is the angle between them. Okay, so in this case A and B would be 7 and 8 and C would be 45. So the area of this triangle is a half times A, which is 7, times B, which is 8, times the sine of 45 degrees. Just subbing in from what we had from the diagram. So there's my 7 going in there, there's my 8 going in there, and my 45-degree angle we already talked about. Okay, right, so just tidying that up, I'm going to divide the half into the 8, and that's going to give me 4, and then 4 times 7 is 28, so that's 28 lots of sine 45. Okay, now we want it in the form of A root B, which is an exact form. So we're going to have to use our exact values of our trigonometric angles in order to progress further in here, because we don't have a calculator. So now there's a handy table that you need to remember in order to work out your exact values. I'm going to quickly show you here how I do it. We need to know the angles of 0, 30, 45, which is the one we need today, 60 and 90 for sine, cos, tan. Now I only really do this as far as I need to get to, so I'd probably bail out quite early in this one, but the basic form of it is you take root 0 over 2, root 1 over 2, root 2 over 2. Now that's all I need for this one, so you know, if this was me working the problem out, I've already got the solution here, but I'm just going to show you what the rest of the table looks like as well. So that'd be root 3 over 2, root 4 over 2. So notice that the numerators are all going up by 1, aren't they? Root 0, root 1, root 2, root 3, root 4. That's not really hard to remember. And the numbers on the bottom are all 2s. 2, 2, 2, 2, 2. Okay? Now, for cos, they just go the other way around. So you write the same thing down but backwards. So you're going to get root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. Okay, and then the tangent you get by dividing the numerator part of your sine by the numerated part of your cos. Okay, so this one would be root 0 over root 4, this would be root 1 over root 3, this one would be root 2 over root 2, this one would be root 3 over root 1, and this one would be root 4 over root 0. Now, if you remember it this way, quite a lot of them you have to simplify before you write them down. So obviously, look here, I've got root 0 over 2 here. Well, root 0 is just 0, and 0 divided by 2 is just 0. So if you do it this way, you do have to kind of simplify some of them down before you use them. But I think it's a whole lot easier to remember the exact values because they're all a little bit esoteric. Okay, so and as I said before, I probably wouldn't do all of this in the exam. I'd only write down as much as I need and then quit because I don't need all this information. So after I'd written down the pattern as far as kind of here, I'd have stopped already because I've got everything I need already. I just want sine 45 and I got it at that point. So don't feel like you have to write out the whole table every time. Just write down as much as you need to get the number that you need in order to get the answer that you need. Okay, so here I'm going to get 28 sine 45 we just worked out to be root 2 over 2. So 28 times root 2 over 2. So 2's into 28 go 14 times. So that comes out to be 14 root 2. That's my final answer. 14 root 2. Question 18a. By factorising, find the roots of y equals x squared plus 18x plus 77. Okay, So I need to factorize factors of 77. What are they then? Let's see if we can work out some factor pairs of 77. So we've got 1 and 77. What other numbers go into 7? I suppose 7 does. 7 and 11. Is that it? I can't think of any more. 2 doesn't. 3 doesn't. 4 doesn't. 5 doesn't. 6 doesn't. 7 doesn't. 14? No, 14 doesn't. I think it's just those two. 1 and 77 and 7 and 11. I think it's going to be 7 and 11 because 7 and 11 add up to 18, which is the middle term. So I think we're going to go for this pair here. 7 and 11. So x plus 7, x plus 11, like that. Okay? So if that is the case, then the roots occur when y is equal to 0. It's where it crosses the x-axis, which is the line y is equal to 0. So when y is equal to 0, then x plus 7, x plus 11 is equal to 0, in which case x is equal to minus 7 and x is equal to minus 11. Okay, so they're my roots. Minus 7, minus 11. Part B says, write y equals x squared plus 18x plus 77 in the form y equals x plus a all squared minus b. Now that is the completed square form, isn't it? Now this number here is always half of the coefficient of that term there. So it's going to go into something that looks like x plus 9 all squared. Okay? Now if we're going to replace, if we're going to do the difference, but if we're going to do that, x plus 9 all squared actually gives us x squared plus 18x plus 81. So we've introduced 81 more than we should have. So we need to take that one away again, 81. It's the square of the 9. So after you halve the 18, you get 9. It's x plus 9 all squared minus the square of 9, which is 81. But remember we had the 77 that was there already, and we've still got that 77. So plus 77 in there. So just tidying that up then, I've got y is equal to x plus 9 all squared and minus 81 plus 77. Those two numbers have got a difference of 4, haven't they? So it's going to be minus 4. So y is equal to x plus 9 all squared minus 4. Right, part 2 says write down the coordinates of the turning points of the graph. Well, we just worked out that the completed square form was y equals x plus 9 all squared minus 4. So the turning point of this graph is the lowest possible value it can be, and that occurs when this part here is equal to 0, because any number squared is a positive number. So the smallest value a square can be is when it's 0. So what value of x makes that bracket equal to 0? It's going to be x is equal to minus 9. So when you add 9 to it, you get 0, and 0 squared is 0. Okay? And when x is minus 9 and that bracket becomes 0, then y is going to be equal to what's left, because the bracket is going to be 0. So y is equal to minus 4. So y is equal to minus 4. So x is minus 9, y is minus 4. Job done. Question 19a, sketch the graph of y equals 5 to the power of x, indicating any values where the graph crosses the axes. Okay, so this type of equation is what we call an exponential curve, and this value here is pretty irrelevant. They always look the same. Okay, if you've got an exponential curve, it's going to look like an exponential curve. It's going to look like this. And they always pass through the origin at 1. Okay, because what to the power, 5 to the power what is 1, it's going to be 0, isn't it? So it always passes through. 5 to the power 0 is 1, 6 to the power 0 is 1, 100 to the power 0 is 1. It always passes through 1. Always has that same shape. So on the left hand side, just to be clear, this is approaching but never reaching the axes. So it shouldn't kind of bend up or touch the x-axis. If it does, you're going to lose marks. So how to lose marks in this question: if I either crash into the axis like that, that would be a no-no. Also, if I kind of went up again, okay, even slightly. I mean, I did it really exaggerated here, but you know, if your line looks more like that, and even if it just kind of flares up a little bit at the end, you can lose the mark. Okay. The other thing is at the other end, your gradient is always increasing. Okay, so it shouldn't have any flat sections, it shouldn't have any straight sections, it shouldn't kind of wobble. It's constantly increasing. Okay, so that's how you draw an exponential curve. B, sketch the graph of y equals tan x from 0 to 360 degrees, indicating any values where the graph crosses the axes. Okay, so the tan curve, it has a period of 180 degrees. I'm just going to quickly sketch it first on the left. It looks like this. It's going to have an asymptote there, and it's going to go over again like that. So that's 0, 90, that's going to be 180, that's 270. So it's going to have another little bit going up to 360 like that. Okay, so that's what I'm expecting to draw. Now it's helpful to draw these asymptotes in because it gives you something to aim for when you're drawing the graph. Okay, so let's just measure what we've got going on here. So what we've got, 1, 2, 3, 4, 5, 6. If I halve it, I'm going to get like a mark here. That's going to be 180, about there. And then 270 is going to be like half of that. So there and there. My ruler kind of interferes with me drawing marks. So anyway, it should be like there and there. Okay, so that's my 90 and 270. Now you don't really need numbers on a sketch, but I'm just going to put them in there because I want some guidelines when I'm drawing this. Okay, now I'm going to draw some asymptotes, these kind of lines that it kind of veers up at 90 and at 270. Bit of prep work required when doing tan. Okay, so it's going to cross the axes at 0 and at 180 and at 360. That's where it's going to hit the axes. Okay, and then in between, what's happening? Well, in this section here, look, it's going up like that, tending towards the asymptote but not touching it, and then it kind of goes around the universe and reappears down at negative infinity, passes through 180 like that, and then kind of then goes back up towards infinity in that direction, goes around the universe one more time, and then crosses again at 360. Okay, I don't think that's too bad. So something that looks like that. Question 20. Kai has a box in the shape of a cuboid. The internal dimensions of the box are 10 by 4 by 6. Kai is given a pencil of length 13 centimeters. Show that the pencil does not fit completely inside the box. Okay. Now, the longest part of a box is going to go from one corner to the other, isn't it? So if you think about it, if the pencil fits, it needs to be shorter than that distance from one corner of the box to its opposite corner on the other side of the box, like that. Okay, so we need to know that distance. Now there are different ways of doing this. There's an easy way and there's a hard way. Okay, now the easy way is to use the extension of Pythagoras Theorem that works in 3 dimensions. The not so easy way is just to use the plain old 2-dimensional version and apply it multiple times. Okay, so if you think about it, just kind of forming a triangle here. So what you could do is you could use Pythagoras Theorem in this triangle first. Okay, so work out, because you know 10, you know one side is 10 and you know the other side is 4. So if you use Pythagoras Theorem to find this length between the two, that diagonal across the bottom, and then we already know this side, so then we can use Pythagoras Theorem again with our found side to find it there. But the easier way is to use the length of the diagonal using the 3-dimensional version of Pythagoras Theorem, which says that the length of a diagonal of a box with dimensions x, y, and z is just going to be the square root of x squared plus y squared plus z squared. Okay, so you just take the 3 dimensions of the box and you square them all, add them together, and you square root. Okay, this works for any cuboid. So if you take the 3 dimensions of your cuboid, you square them and add together the square root, then that is going to be the length of the longest diagonal in the box. Okay, so this is just a fact. You can use it as an extension of Pythagoras Theorem. If you don't believe me, you do it the long way first, you'll get the same answer. But, you know, why would you bother doing boring old two-dimensional Pythagoras theorem twice when you can use super amazing three-dimensional Pythagoras theorem just the one time? Okay, so just taking our three lengths then, 10, 6 and 4, squaring them, 10 squared plus 6 squared plus 4 squared, and then rooting. What's that then? So 10 squared is 100, plus 6 squared is 36, and 4 squared is 16. So what's that then? So that adds up to 152. So this box has a distance of 152 rooted. Now I know that 13 squared is 169, so that 13 squared is 169, therefore root 152 is less than 13, isn't it? Okay, so we know that the root of 152 is less than 13, therefore pencil will not fit in box. Okay, so I don't have a calculator, so I can't work out the root of 152, but I know the root of 169 is 13, so the root of 152 has got to be smaller than the root of 169. Okay, question 21. The graph y equals 1 over x minus 2 is drawn on a grid from minus 2 is less than equal to x, which is less than equal to 6. There are no values for x of which 1 over x minus 2 is equal to k. Find the value of k. Now this is a bit of a weirdly worded question. Now remember that 1 over x minus 2, that's this thing here. So basically that's what y is. So it's saying there are no values of x for which y is equal to k. Okay, so I think what this is saying is that what is the value of y for which there is no corresponding value of x? Okay, so if you have a look all the way along here, look, so if y was 8, there's a value of x. If y was 6, there's a value of x. If y was 4, there's a value of x. If y was 1, there's a value of x. If y was minus 2, there's a value of x. If y there's minus 4, there's a value of x. But if y is equal to 0, there is no value of x anywhere along this line because the line doesn't cross it. Okay, so which value of k are they talking about? I think what they're talking about here is the value 0. Okay, because for every other value of y, there is a corresponding value of x. But for that particular value of y, y is 0, there is no value for x that gives you an answer of 0. Okay, you can't put in a value of x into that function and get the answer 0 out of it. Okay, so that is the value that they're looking for there. A bit complicatedly worded, that one. I think they could have asked it in a nicer way, but anyway. Part B, use the graph to find the approximate solutions of the equation 1 over x minus 2 is equal to 3x minus 1. Okay, well remember again, look, this is our function that we've been given, this is our y value, and now we've got a new function 3x minus 1. So if we plot on the graph y is equal to 3x minus 1, then where those two lines cross, they will be the solutions to my graph. Okay, now when I draw a linear graph like this, I just know that that's m, the 3 there is going to be my m value, so it's going to have a gradient of 3, and sorry, a y-intercept, I wrote minus 1 again, I meant to write plus c, and then the c value of minus 1. Okay, so that means that my line I know passes through the y-axis at minus 1, so it's going to go through that point there. And because it's got a gradient of 3, for every one that go along, I go 1, 2, 3 up, so there's going to be a point there. 1 along, 1, 2, 3 up, it's going to be a point there. 1 along, 1, 2, 3 up, there's going to be a point there, and then it's going to be off the top of my graph. Okay, so I've got some points. Maybe I can plot one lower as well. 1, 2, 3 down, and 1 to the left there. Okay, so I've got my points. I can now join them up with a straight line. And where this line crosses my curve, then that should be the solutions to the equations that they're asking me for. Okay, so I'm just going to draw that like that. So you can see there's a point of intersection kind of here, and there's a point of intersection down here. So I just need to read those coordinates off carefully. But I don't need the coordinates, I just need the x value, don't I? Just need the x value. Okay, so what's that x value there? Can you see it's like one little square beyond 2. Now there are 5 squares between 2 and 3, so I reckon that must be about 2.2 on the right. So I'm going to write that in the right hand box. It's on the right, 2.2. And then the left one, what's that? 0.2? 0.2, something like that. So you need to be within 1/2 square of accuracy here. I think I am. Half a square would be like 0.1. So anything between 0.1 0.3 probably is acceptable on the mark scheme. Haven't checked, but I guess that's what it would be. Let me just check. Yeah, what I thought. So the mark scheme says 0.1 to 0.3 or 2.1 to 2.3 as acceptable answers. So I'm all good there. Right, now finally, show algebraically that 1 over x minus 2 equals 3x minus 1 has the same solutions as 3x squared minus 7x plus 1 is equal to 0. Okay, so in other words, we need to cross multiply and form a quadratic. So multiplying both sides by the denominator on the left hand side, this part here, I'm going to cross multiply x minus 2 or multiply both sides by x minus 2. Either way, I'm going to get 1 is equal to 3x minus 1 times x minus 2. Okay, now multiplying out the brackets using FOIL, first outside inside last, I'm going to get 3x squared minus 6x minus x plus 2. That's still equal to 1, isn't it? So then collecting like terms, I've got a 3x squared term. I've got a minus 6x and a minus 1. That gives me minus 7x. I've got 2, but remember I've got 1 this side, so taking the 1 away from both sides, I'm going to get 0 is equal to 3x squared minus 7x plus 1 on that side. So I've done it then, okay, as required. Okay, it's all done. Lovely job. Okay, I think that's the end of the paper too. Huzzah. Right, I'm out. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.